Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to give you another code review. I'm giving you a code review on the Kaggle community competition called Regression Rumble, and I made a artificial neural network with TensorFlow to solve this problem. And basically what we're going to do is we're going to go over the code with it. Whenever I ran up the program, I had a 0.62255 as my public score. So that was pretty good. I didn't get on the leaderboard because I entered the competition after the competition had already finished. But with Kaggle, you can still do competitions after they finished. You just don't get put on the leaderboard. So here's the problem statement to this regression problem. A regression-based problem. Identify the mysterious columns to decipher the relationship between the features and predictions. So the first thing that we wanted to do was we wanted to import the libraries. So we're going to import NumPy as NP, which creates NumPy arrays and performs numerical computations. We're going to import Pandas as PD, which creates data frames and performs data processing operations. We're going to import OS, which goes into the operating system and does things. We're going to import matplotlib.pyplot.splt, which visualizes the data, and we're going to import Seaborn as SNS, which also visualizes the data. Now, inside the program, we're going to import sklearn, which provides machine learning functionality, and we're also going to import TensorFlow, which creates the neural network. So after we have imported our imported our libraries, what we're going to do is we're going to get the files, and we're going to use OS to go in and get the files. So for dir file name, dir space file names in os.walk, kaggle.input. For file name and file names, print os.path.join, dir name file name. And then so it gives you the directory name, and then it also gives you the file name. So that tells you that there are 3 files of CSV in the directory that you're going to use to create the program. So what we're going to do is we're going to read the files, and we're going to use pandas to read the files. So train equals pd.read CSV, and then you got the file name for data, but I called it train. And then so we're going to create 3 data frames called train, test, and submission. So you can see here's the train file. You've got your ID, which that's probably something I can do. I think I forgot to delete the ID, so I might be able to improve my score by deleting the ID. So after I have completed this code review, I'll go through and delete the ID, and maybe my score will improve. And then you've got X0 to X9 columns, and you've got Y. So what you have to do is you have to determine which columns don't fit the prediction. So we've got train.info, tells you the first column is an integer and the rest of them are floats, but I will drop the ID column because you don't need the ID column, and the reason why you don't need it is because every row is already indexed. We check to see if there were any null values, and there's not any null values, so you don't have anything to impute. And then what we do is we check the test, and the test has everything except Y because Y is your target. We check for null values, and you can see that there's no value, so you don't have anything to input. And then we've got our submission. This is what Kaggle wants to see when you submit your work. Now what we're going to do is we're analyzing our target, and then you can see the target is a normal distribution. And we're going to analyze our target by target equals train.pop_y, and then we're going to use a displot, sns.displot target, KDE equals true, and you can see it creates a normal distribution. We do a value count, and everything is 1. So now what we're going to do is we're going to use Kolmogorov-Smirnov to sample test, and we're going to see which columns in train and test are not from the same distribution. So to drop is a blank array or blank list. For call in test, stat pv equals stats.ks underscore 2sam, train call, comma, test call. If pv is less than 0.05, print call is not drawn from the same distribution, then to drop dot append call, and then you print your to drop, and then you drop the columns from train and test. So x2 and x3 are not from the same distribution because they're less than 0.05, and so we printed off what is in to drop, which is x2 and x3. And then this is our new data frame when we have dropped x2 and x3, because the thing is if those columns are not from the same distribution, they're not going to add anything meaningful to the prediction. Then we have a heat map, and you can see when we have the heat map that the columns are not highly correlated to each other, but we check the correlation anyway, and you can see that they're not highly correlated. Now we define our x and our y variables. Y is your target, x is your train, and then we use sklearn to split the x and y variables into training and validation sets, and then we check the shapes of the new data sets that we have created. So now we're getting into TensorFlow because we're going to be creating our neural network. So we import all of the libraries and modules that we are going to need. And you can see that we're using TensorFlow 2.11. We're going to create our first row of the neural network by standardizing the data. Normalizer equals normalization, axis equals -1. When you have axis equals -1, I think that means it's normalizing all of the columns. Normalizer.adapt, np.array xtrain, print normalizer.mean.numpy, and so you can see that these are all of the normalized means of every column. And so now what you can do is you can see what the one row looks like when it hasn't been normalized, and see what it looks like when it has been normalized. Now what we're going to do is we're going to define our artificial neural network. So model equals sequential, name equals regression rumble, model.add normalizer. So that's the first row of the artificial neural network. Model.add dense is 20, so we said 20 neurons in the first hidden layer, and the input to the first layer is the shape of xtrain is number 1. The activation is ReFlu, and the name is hidden 1. The second hidden layer still going to have 20 neurons. Activation equals ReFlu, name equals hidden 2. And then the last the last layer of the artificial network, it's going to have one neuron because it has only one output. Activation equals linear, name equals output. So we've got a summary of the model, and you can see what the summary is. Now what we do is we compile the data into we compile the model. So the loss equals mean squared error, optimizer equals atom, and metrics equals MAE. And then we set up early stopping as monitor equals valve loss, mode equals min, patience equals 25, verbose equals 1. We set up model checkpoint, so best model.h5 is going to be the best model that it selects. Monitor equals valve loss, mode equals min, save best only equals true. And now what we're going to do is we're going to train the data. History equals model.fit, x train, y train, epochs equals 200, validation data is x val, y val, batch size equals 32, and then callbacks is early stopping and model checkpoint. And then so it trains the data for 200, which I could have trained it for longer if I had wanted to. So it doesn't take that long to do it. I didn't even have it on a GPU, and it didn't take that long. But if I wanted to, I could train it for longer and maybe improve the score. Who knows? And then so this is the a graph of the loss and the MAE. So you can see the loss is the blue and the green, and the MAE is the orange and the red. So you can see the val MAE is more than the training MAE. So now what we do is we predict on the validation set, and you can see there's lots of negative numbers. So you've got ypred equals model.predict xval, ypred equals ypred.astypeint, ypred equals ypred.flatten, and then ypred. But let's see what we've got over here in our submission. So the submission is just 0, so I made it an integer. Ypred equals ypred.flatten, and then you got your ypred. Now we check the root mean square, and the root mean square is 0.64, which I think is pretty good. And RMS equals np.sqrt, brackets, it means squared error, yval, ypred. And then we graph it, we put it on a graph, and you can see I think it looks great. I think it looks fabulous. You know, all of the predicted values are right on the actual values, so I think it's really good. And then so what we do here is we have a df val equals data frame, and then so we've got the actual value versus the predicted value. But I think what I'm going to do is I'm going to take the int off and see if I can improve my score if I take off the int. So I've got two things that I can do to try to improve my score. Is one is remove the ID, and two, take off the int. And then we predict on the test set, which was the same basically as predicting on the validation set, and using pretty much the same code, except we exchanged predictions for ypred. And then I put it on a displot, and you can see that it's got a normal distribution. But I've got two things now I can do to try to improve my score. And then we prepare our submission. And then whenever I submitted it to Kaggle, I had a best score of 0.64293. So what I've got to do now is I've got to do two things to try to improve the score. Number one, remove the ID, and then number two, take off the integer as type and see if that will improve my score. So we'll give that a go, see what happens. And thank you for watching my code review. I really do get a lot out of giving code reviews because they help me go over the code and help me think about things that I can do to actually improve my score. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And if you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you again for watching my video. I look forward to making more code reviews for you in the future.